Hey, 7th graders and honor 6th graders. We're back again to talk about proportional relationships in lesson 11. So I already wrote out the equation for proportional relationships. Remember, it's y equals k times x, where k is the constant of proportionality. Okay, I gotta abbreviate that because I ran out of room. And then y and x are just your y and x coordinates, whatever they might be. Okay. Remember, your constant of proportionality is y over x. That's always your constant of proportionality, okay? All right, so here it's showing me a graph that is proportional. The reason I know it's proportional is because it goes through the point 0, 0, okay? And it's a straight line. So this is a proportional graph, okay? Because it fits two of my things. It fits the equation y equals kx, first of all, okay? So that's three things. It goes through the point 0, 0, and it's a straight line, okay? Those are the things I know that are going to tell me it is a proportional graph, okay? So I can just look at the graph, I know it's proportional. All right, this one just says invent a situation that could be represented by this graph. All right, so let's say they used lemons and lemonade earlier. I have no idea how to make lemonade, so I'm totally making this up. So let's say my x's are lemons, and this is water. Okay, so what it's saying is that, so I can pick out some points, is it's telling me how much water. So if I had 16 lemons, I would add 12 ounces of water. I'll say ounces, I don't know. Okay, so what I'm saying is this would be a recipe for lemonade. Okay, so I'm kind of saying for every points that I can actually make out, for every 16 lemons, I'm going to add 12 ounces of water, okay? Every 16 lemons, I add 12 ounces of water. Oops. Ounces of water, okay? And that just is from that point right there. It's proportional, so it will match every point on this graph. So if I looked at this point, that means if I used 8 lemons, I need 6 ounces of water, okay? Probably cups of water. Let's make that cups of water. Ounces doesn't make sense. Here are cups now, okay? So let's make that cups of water. So that's one situation I can make out of that. I could say I paid $8 for 6 Sharpie pens, okay? So I could make up any situation that fits this graph. Okay, we labeled the x's with the quantities in our situation, so lemons and cups of water, okay? If I title the graph, all graphs need a title. We'll call it lemonade recipe. Okay? It says there's a point on the graph. What are its coordinates? So the point that they gave us at first was 16, 12, where x was 16, y was 12. And that's kind of what I wrote up here. For every 16 lemons, I would add 12 cups of water. That's what it's going to tell me. 16 lemons, I add 12 cups of water. Okay? All right, if I wanted to come up with the constant of proportionality, I can. It's not asking me to, but I can. Okay, so what I would do is I'd say 16 over 12. 16 over 12. I would do 12 over 16, my y over x. Okay, that would give me 12 over 16. So I would just reduce that, divide by 4. Divide by 4, I would get 3 over 4. That's my constant of proportionality. So if I wanted an equation for this graph, the garbage truck is coming. I don't know if you can hear it outside. I would have y is equal to kx, and the y is equal to 3/4 x. Okay, so that would be my equation for this. All right, so that's that one. Kind of just a little bit of a review on what we've been doing. All right, let's move on to the next one. This one, it's saying that Tyler was at the amusement park. He walked at a steady pace from the ticket booth to the bumper cars, okay? The point on the graph shows his arrival at the bumper cars. What do the coordinates tell us about the situation? So this is how long he walked in seconds. This is the distance from the ticket booth. So if he's at 40, 50, it means he walked for 40 seconds and is now at 50 meters from the distance, or from the ticket booth, okay? So at 40 seconds, he's 50 meters away from the ticket booth. At 40 seconds, Tyler is 50 meters away from the ticket booth. Okay, that's how I would read that graph. Okay. The table represents Tyler's walk. The table representing Tyler's walk shows other values of time and distance. Complete the table and plot the pairs on the grid. Okay. So it's saying at 0 time, he was at 0 distance. Okay. He was at the ticket booth. In 20 seconds, he was 25 meters away from the ticket booth. In 30 seconds, when x is 30, y was 37.5. That'd be right about here. 40, 50 is the one they gave us. All right, so it's asking me about 1. How do I figure that out? Okay, so this is, I have to figure out my constant of proportionality. So I'm going to take 2 of the ones I know, my y's and my x's. Let's use 50 and 40, okay? So if I do y over x, okay, 50 over 40, I'm just going to divide by 10 because I want that in lowest terms. So that would be 5/4. So he is 5/4 meters away, or 1 1/4 meters away. Okay, so that's how I would figure out the y here. I'm going to find my constant of proportionality, which is always going to be when x is 1, okay? So that's how I would figure out that one. So when I plotted them on here, I should make a straight line if I could draw straight. Oops, that didn't work. Okay, and it would keep going. What does the point 0, 0 mean in this situation? It means he has walked 0 seconds. Okay. And the other one was telling me the meters away from the ticket booth. He is at the ticket booth. Okay. So it's showing me that he's walking to the bumper cars, but here's his starting point. So in other words, this is literally his starting point. This is another one of those graphs that I could not have a negative number. I can't be negative seconds away from something, okay? Okay, so how far away from the ticket booth was Tyler after 1 second? Well, when we figured out our chart, okay, it was 1 1/4. So he was 1 1/4 meters. I got that from when I figured out y over x, okay? Label the point on the graph that shows this information with its coordinate. All right, well, there's not exactly a 1, and there's not exactly 1 1/4. So it's got to be on my line. So I'm saying if that's about 1, that looks like it would be about 1 1/4, okay? So it's very close. All right, my last question on here says, what is the constant of proportionality for the relationship between time and distance? Okay, we figured that out already. This was my constant of proportionality. Okay, so K, your constant of proportionality, was equal to 5/4 or 1 1/4. They're the same thing. Okay. What does it tell you about his walk? It's telling us that for every 1 1/4 seconds, or for every 1 second, he walks 1 1/4 meters. So Tyler walks 1 1/4 meters per second. For every 1 second, he walks 1 1/4 meters. Okay? So it's just interpreting this graph. It's a proportional graph. It's interpreting what everything means on there. So if I looked at the point 20, 25, that means in 20 seconds, he was 25 meters away from the ticket booth. Okay? 40 seconds, he was 50 meters away from the ticket booth. All right. This one says, if Tyler wanted to go get to the bumper cars in half the time, how would the graph represent his walk change, and how would the table change? Okay, so if he wanted to go faster, get to the bumper cars faster, he's in a hurry. Okay, so he wants to get in half the time. So that means he would still start at 0, 0. I'm just gonna make a table. Okay. Okay, my old graph showed me that, and I'm just gonna use the whole numbers they used. They told me that I'm gonna find the graph again. In 20 seconds, he walked 25, okay? So if he did half that time, it would be 10 seconds. He walked 25 meters, okay? Does that make sense? So if he did 40 meters, what, 50, was it 40, 50? Yep. So when he did 50 meters, instead of 40, I would do 20, okay? So if I were to graph that, what's going to happen, and I'm going to graph it on the other page just to show you, okay? What's going to happen is this graph is going to look different. And what about the constant of proportionality? Well, if I did 50 over 20, y over x, I'm going to get 5 over 2, or 2 1/2, okay? So that's him going twice as fast. It doesn't mean that everything's going to be times 2 or half of it, okay? He got the same distance in half the amount of time. All right, on this graph, this other graph we did, we're going to graph this. So if in 10 seconds, and I'll graph it in green, if in 10 seconds, instead of, what was my other one? Let me look at my original one here, okay? Oops, I'm on the wrong graph again. No wonder it looked weird. Sorry. I'm like, that doesn't look right. All right, so in 10 seconds, we're saying he walked 25 meters. In 20 seconds, he walked 50 meters, okay? He's still going to start at the same point. But now my graph's going to look like this, okay? So it's going to be steeper is what my graph is going to look like because he's going faster. My constant of proportionality would be here where it's 1. This would have been about 2 1/2, okay? So that's just showing you what happens if I change some information, okay? So this was the constant of proportionality. This is how the table changed, okay? And the graph became steeper. That means it went up at a higher rate. Okay. So we're going to do one more graph together, and that's it for today. Good way to end the week. All right, it says 4 seagulls ate 10 pounds of garbage. Assume this information describes a proportional relationship. That means 0 seagulls ate 0 pounds of garbage. Okay, so that means it had to start there. Does that make sense? It's proportional. It has to go through the point 0, 0. Plot a point that shows the number of seagulls and the number of garbage they ate. All right, so if I have, I'm going to make this X, Y chart. This is seagulls. And this is garbage. Okay. So I know that 4 seagulls ate 10 pounds of garbage. Okay. What else do I know? Well, I can figure out my constant proportionality. Or I could just say, okay, if 4 seagulls ate 10 pounds, that means 8 seagulls ate 20 pounds. 16 seagulls ate 40 pounds. I could do it that way too. Okay. I can also find my constant of proportionality, which would be 10 over 4, my y over x. And I would just reduce that. 2 goes into both of these, so this is 5 over 2, or 2 1/2. So that means for every 1 seagull, they ate 2.5 pounds of garbage. So 2.5 pounds of garbage per seagull. Okay, so now I can graph it. I know for 1 seagull, he ate 2.5 pounds of garbage. I know for 4 seagulls, he ate 10 pounds of garbage. Okay, I can't do 8 and 20 on this graph, so I'm going to have to come up with some other points. So 2 seagulls would eat 5 pounds of garbage. 4, 5. Okay, I could do it that way. I could do my 1 seagull, or I did my 1 seagull. 1 seagull was 2.5. I just forgot to put them up here. Okay? Okay, so if I attach this, I am horrible at drawing straight lines. I should have got a ruler. That just would keep going because the number of seagulls could increase. That means the number of garbage is going to increase. Okay? So I could keep filling in things that are equal in my table. Okay? Or I could literally figure out the points on the graph. All right. It says plot a point that shows the number of seagulls. We did that. I didn't use a straight edge, but you get the idea. We went through the point 0, 0 because it's proportional. Plot the point 1K on the graph, okay? We've done that already. We're saying that when x was 1, this is this one. When x was 1, y was 2.5, which is also my constant of proportionality. That was my y over x, okay? What does the value of k tell you about this context? So my value of k was 2.5, and it tells me that each seagull ate 2.5 pounds of garbage. Okay, so this lesson was all about interpreting the graph, being able to figure out if it is proportional, or if it is proportional, why is it proportional? This one is because it went through 0, 0, and it makes a straight line, okay? All of my points will be proportional. That means they will reduce to the same thing. Every point will reduce down to 2.5 over 1, okay? Or 5 over 2, same thing. All right, so on your lesson summary, which is this page, it kind of goes through another example, okay? It gives you the equation, so what you need to know on here is that this is the constant of proportionality because y is always equal to kx, okay? And it's giving you another example of a graph that's a proportional graph. It goes through the point 0, 0. It makes a straight line, and all of these points will be proportional. All right, I hope you guys have a fantastic weekend. And again, hope to see you soon. I'm going stir crazy at home, so I'm sure everybody else is too. Bye.